Check. TV/Johnny Marler, I think. What is my channel name? Johnny Marler, okay. Does that link work? Posting on Discord that I'm streaming. Okay. Let's go a little bigger here. Oh, I should get Bork going again, huh? It's been so long. I gotta remember how to do everything. Okay. How to Bork. I think I just have it in my path, Bork. Bork start. Okay. Well, I think it's running. I could send a test message. Cool. So I have a baby monitor that I created. And right now I'm using this tool called PyCam. GitHub PyCam. Here it is. And there was a couple of bugs with this. I think I actually pushed a couple of fixes to it. But it's all in, I forget what language it's written in now. I think it's in C++. Yeah. But I've recently been working on webcam stuff, and I think it'd be pretty easy to spin up a server in Zig to serve up the webcam so that I could use my custom baby monitor Raspberry Pi and just run code that I've written. Should be pretty cool. So yeah, that's what I'm going to be doing. So we started with a blank slate here. We'll be using my X library that's written in Zig to display the graphics, and then we'll be using the video for Linux interface. So this will start off just running on Linux. And that's about all we need to get this to work. So let's get something going here. Video server. This will be on GitHub. And I made a repo called Media Stream. So let's go ahead and get that repo initialized here. I think GitHub switched back to using master as the default branch. They were like, let's use main, and then they're like, ah, never mind. So we're back to using master again, I guess. Okay. So we got an empty repository. We've got our build.zig with a run step. And I think Should be able to zig build run. Yep, okay, cool. So where do we want to start here? Maybe let's start getting the graphics going, and then we can, after that, try to hook up video. But let's get something like push to the screen first, potentially. So we're going to add a dependency here. And to do that, I'm going to use my git repo step code in build.zig. So let's copy that from another repo. Let's import it here. And then let's go ahead and get our repo, our X11 repo. I think it's create. And I think it's like URL. And then branch equals null, and then SHA equals something. So let's figure out what SHA this is supposed to be. BBEF. Okay, so now our exe is going to depend on this repo. exe.step.depend on zigx repo.step, and then we'll add it as a package. zigx, and then what is it? It's zigx repo.get path, and then you give it a step, and this will like make sure you've added it as a dependency. And then we probably want to do b.pathJoin. So I think it's x.zig is what we want. Okay. Did I make any mistakes? Yes, I need to add the builder. Oh, is that the only one? Yeah, I think so. Cool, so now if we add fetch to our build, it'll automatically fetch that repo for us. And now we should have it available as a package. So if I go up here, const x equals import. Actually, I should probably just call it x instead of zigx. Cool, okay. So now it's going to be in our dep folder here. That's where the git repo step downloads everything. So maybe we start with the example from there. So cp dep zigx example.zig. And we're just going to overwrite whatever we have now. Okay, so we've got our example X application here. This will be changed to X. We don't have this common thing. A memory file descriptor will probably want that. And then I think this needs to be x.contiguous read buffer, maybe. Okay, maybe let's copy the common stuff really quick just to get it running. Okay, zig build run. Let's see what that does. Oh, the common file needs to be able to find X. There we go. Cool. So we've got our X window. It says hello X. And I actually don't know how to get arbitrary pixel data onto an X window. And we're going to need that to be able to display video. So let's do a bit of research real quick. So X11, let's see. Maybe let's look at the X11 documentation real quick. So it's going to be in zigx x.zig. I think I have a link to it. Yeah, here at the top. Let's look at the protocol real quick. Maybe we'll find it quickly there. So we're looking for something like if we want to draw rectangles, I think it's called draw rect or fill rect. Polyfill rectangle. Okay. So I wonder if there's like a poly or like a draw buffer or fill buffer or something. This could also, if you want it to work remotely, you might need something like that. Or maybe we don't want it to work. Maybe we only want it to work locally, and then we could use like a shared memory extension, which I think might be a common way to do this. I think they might have a section which kind of talks about the different drawing commands in a single place. X protocol. Let me look at the table of contents here. Okay, this is the format of the protocol. These are all the types. Okay, here's errors, keyboards, atoms. Okay. Screen information, visual information, create window. Okay, yep. Change window attributes. Map window. It's kind of like showing you everything in the order that you would need to like learn it or need to set up a window so far. Okay, querying stuff about the system, properties, send event, okay. Grab pointer. This grab pointer thing is weird. I still don't quite understand exactly how it works. I've done a lot of experiments with it, and it's just very underdocumented, and it behaves very oddly. Query pointer, get motion events, warp pointer, open font. Okay, now we're getting into fonts. Okay, now graphics context. So I think after this, I'll probably start getting into the drawing commands. Clear area, okay. Are we using clear area here? Render, oh, we are right here. There's a clear area. Copy area. Source drawable. That's interesting. Like, if you could create an area and then populate it with arbitrary pixel data and then maybe copy it, maybe there's something like that we might want. Copy plane. Okay, this is interesting. So you get a graphics context. You give it like a rectangle within it, within this plane that you're copying, and then a destination. Okay. So plane. Polypoint. This request combines the foreground pixel with the pixel at each point in the drawable. Huh. Okay, I actually don't know what polypoint does. Combines the foreground pixel in the graphics context with the pixel at each point in the drawable. The points are drawn in the... So is it just drawing individual pixels? Or maybe this is like a way to give it points and then you tell it like enclose these points or draw or fill these points or something. I thought it was kind of what polylines was, but and then poly segment. Okay. Poly rectangle, poly arc, fill poly. Okay, that's another list of points. Polyfill rectangle, polyfill arc. Put image, here we go. I think this is what we were looking for. Data list of byte. Yeah, this is kind of what we want. So this request combines an image with a rectangle of the drawable. Okay, drawable would be like your window ID, for example. It's interesting language here, combines. The destination coordinates are relative to the drawable's origin, so that'd be relative to the window's origin. if bitmap format is, oh, they have different formats. So you can give it a bitmap, an XY pixmap, or a Z pixmap. I do not know exactly what these formats are. Okay, the foreground pixel in GC defines the source for bits. Okay. I'm not quite grokking this yet, but for these pixmaps, the depth must match the depth of the drawable. Okay. The left pad must be 0 for Z pixmap. Okay. Don't quite know what that means yet. Okay, GC components. Okay, cool. So, and then, oh, then there's a get image. Interesting. Okay. Well, this is what we want, is this put image. And then, like, I suppose we would only need to resort to, like, shared memory if we were having a performance issue. Cool. Color map. I wonder if we would need a color map to be associated with our put image. But let's try to get put image to work. So let's put this over on the side here. And see if we can get it to work. So let's open up our ZigX repo. And let's add our new command put image. Let's open up another tab so we can keep this spot. And then let's find where it defines the command. So here's at the end of the documentation here is where it lays out all the commands in sort of their format, their encoding. So the first thing we look at is its ID number, or its opcode is 72. So I'm going to go down here and I have a type somewhere here where I define all the opcodes. I don't know, let's look up clear area. Okay, so here it is. So we've got a put image command. 72, okay. The next thing we do is we define the actual a subtype to serialize the command. So it's next to polyfill rectangle, so that's where we'll put it in the code. And we can copy this one. It's kind of nice to like find a similar one to copy from, but let's just start with this for a second. So put image. Okay, so then what I did here was, it depends on if the command has like dynamic data or not. Put image here, I believe is going to have, yeah, it's definitely going to have dynamic data, but like something like clear area, like this is the clear area code. All you have is a length and then a method to serialize it because there's nothing dynamic about it. So non-list length, I suppose it's called that because typically most commands have like a single list. So it's like, here's the static part of the command and that's length. Is that the case here? It looks like it might be. So we've got 2 bytes here, 2 bytes, and then another thing to know is pretty much everything is 4 byte aligned. So 4, 4, 4, 4, and then 1, 1, 2. Okay. And then the here's the actual image data and then padding. Yeah, so we only have one list. So same thing here. We'll go non-list length. So opcode and format. And then we've got another 2 bytes, which is the request length, same as the other command. 4 bytes is the drawable ID, same as the other command. And then in the GC ID. And then we get some extra parameters here. Oh, interesting, it's not lined up. Okay, so next would be the width, I think. Width is 2 bytes. And then another 2 bytes for the height. We could just combine that into 4 and say width, height. And then another 4 bytes for the X, Y. And then we've got 2 bytes I remember seeing left pad. I don't really know what left pad is, but we'll say 4 bytes for left pad, depth, and 2 unused bytes, I guess. Just trying to combine things to decrease line count a little here. And then we've got the data. I think that's it. Okay, so now we get the length. To get the full length, we return the non-list length, and then we return the data but padded. So probably we'll need the data length, and then we've got to pad it somehow. I think that's going to be stand mem align forward. Been a little while. Let's look at another example here. Okay, so align forward, data len, and then to 4 bytes, I'm guessing, is the alignment it needs. Could look at a couple more to see if they're all the same. 4, 4, 4. Yeah, everything's 4. Okay, cool. So now we can get our full command length. And then we need a way to pass all of the data for our serialization. So probably, I'm guessing we'll do the same sort of thing here, where we have a drawable ID, a GC ID, those 4 bytes they are, and then we need a width, a height, we need an X, a Y, a left pad, a depth, and I don't know why I put the data as an extra argument outside of args, but I'm going to use that same pattern for now. Data const, it's going to be const u8. I'm kind of wondering like how this would be used. Like, so how we might use this is we might actually pre-allocate the buffer for the command, and then we might fill in the data, because this data could be arbitrarily big. So we might actually fill in the data separately from the arguments. So I don't. This may be the first time where we've had a type that does something like this. Actually, I think I've done it before. Yeah, see, okay, so like image text. Here's an example. So we serialize no text copy. So we might have, maybe we'll have like a serialized no data. Let's look at all of our serialized, see what else we have here. Serialize no name copy. Oh, I see, but we still pass in the name, so it has the length. Okay. And a name here can only be up to 65,000, only up to a U16, so I use a special type to represent that, and maybe that's the same for put image. I think it might be. So let's do this. Let's just do the same thing that we did here. Okay, so serialize. We have a normal serialize, and data will be a slice with a U16 length. And then we'll have a serialize no data copy. Yeah. That, I think, is how we want to do it. You probably need another parenthesis here. Yep, okay. Oh, this is right below us here. So I'm just going to copy that. serialize node data copy, buff, args, and data. And then we'll have a text offset. So this is also going to be a part of the public interface, this offset, so that you can copy the data into the buffer separately from the arguments. So that'll be some hard-coded value, probably non-list lane, actually, wouldn't it? Is it non-list lane here? Yeah, it is actually. Huh, yeah, I wonder why I didn't do that before. Okay. The buff plus data offset. Oh, in this case, we put the data inside of the arguments. Yeah, I guess let's do it that way then. Cool. We don't need that. Cool. Dot text will now be data. Data. Cool. Now we just need to implement the serialization. So one thing we need here is a format. The format is going to be bitmap, xy bitmap, pixmap, or z pixmap. So format pub const image format. I assume this is going to be used elsewhere. It's used here, but it doesn't support bitmap in this case. That's interesting. It's used here. Like maybe we don't make a common type if it's going to be different. Let's not define one yet. Okay, so bitmap equals 0, xy pixmap equals 1, and z pixmap equals 2. Okay. So this will be args.format, and then the request length, which is pretty much the same for everything. We set at the end of the function. Why do we do that? Not sure why. Let's do it at the beginning. Buff plus 2, and then, oh, do I calculate the request len afterwards? Oh, in this case, I copied it from one that was copying a bunch of rectangles. So we're going to go const request len equals non-list len. We're actually just going to call our function here get len. And actually, we don't even need to store it, I don't think. Now let's store it because it looks like we have an assert at the end to check it. Get len. I think we just pass args.data. Args.data.len. And then we'll write the request length after that. Okay. Yeah, they even shift the length over 2 because since it's always aligned to 4, they just drop the last 2 bits, and then you just have to pad it to make sure it's aligned to 4 bytes. Cool. Drawable ID should be next. GC ID is next. We don't need these rectangles. We're going to have width and height next, I think. So 16, buff plus 12, args.width. And we'll have height at 14. And then we'll have X and Y. Which interestingly, it says it's an int 16 instead of a card 16, like kind of making it seem like it could be negative. So maybe we actually want these to be I16s for the position. We can double check what it says about int 16. Could also like look up X colon. Yeah, I do use I16. Okay. So let's do that. I16I. Okay, so 12, 14, and then next one would be 16, and then 18. Put image. Okay. Next we have the left pad, which is a single byte. So buff 20, I think. Equals left pad. Depth would be 21 then. And then we've got a couple of unused bytes. What do we do with unused? Do I zero them out? I do. Okay. $23. And then we've got our data. Okay. We've got an assert here, which we can do that here instead. And then we could do our assert getlen. There's not really an assert we need here at all, actually, I don't think. The data offset should be, we could do like, I don't know, we could do like a comp time assert here, maybe. 24 equals data offset. So it's kind of like in the same place we can see 23, and then the next one should be where our data is. And yeah, that should be all we need. Okay, looks like we're compiling. Let's see if we can actually like send this command over. Let's just send it. I think this is, okay, this is right after we send the hello command. So how do we send commands? Let's do, how do we send a dynamic command is more the question. Do we actually need an allocator here? Let's make a quick little allocator. Arena equals, actually, do we have an allocator? Oh, we do. Arena, what do we use that for? Are we not using this? Allocator. Oh, it's just used there. Okay, well for now we're just going to use an arena. Page allocator. So we're just going to allocate a page for this command for now, and then we'll just deallocate it every time, which is pretty inefficient, but that's okay. Actually, we could use our global arena, and it could potentially be reused. I don't remember if arena would handle that or not, but okay, let's go ahead and allocate our command here. So how do you allocate things? Let's go const message equals, now we go const we don't need to save the length. Const message equals try arena deinit is what I meant to do. Arena dot allocator dot alloc u8, and then we need x.putImage.getLen, and then our data. Let's make our data. XY pix map. Actually, we don't even need an allocator because if we're just sending over hard-coded data that we know the length at compile time, we can call this get len at compile time, which that might be kind of fun to like see. We'll need an allocator like at some point. Well, maybe not. We could like pre-allocate the buffer for it, but let's do it like at comp time for now. That'd be kind of cool. So let's do our data equals, and then let's see if somebody can explain to us what these data formats are. The data for a pix map is said to be an XY format if it is organized as a set of bitmaps, okay, representing individual bit planes. Okay. With the planes appearing from most significant to least significant order. Bit planes. I don't know what a bit plane is, which means for an RGB image, you have all of the red channel data followed by all the green and then all of the blue instead of the more traditional. Okay, so Z pix map is the traditional triplets. Not very clear, as all X11 documentations. I find X11 documentations to be somewhat clear. They're not too bad. Oh, I saw somebody sent a chat. I don't know when they sent it, but Stelios, is this stream still about libc and Zig? What is ZigX? ZigX is an X11 library for Zig, and I'm not doing Zig libc today. I'll probably be going back to that at some point. I probably need to modify my my stream title here. 1 second. So let's see. Writing streaming software. Let's see. Zig writing streaming software. Cool. So not all X11 documentation is clear. Cool. So it might be, I bet you'd be a little simpler to just do a Z pix map. Yeah, it's not majorly clear, but I think that's a description of how you'd probably use. The more practical answer is, this is not the image format you're looking for. Nice. Yeah, I was just doing like code to be able to capture like all the video formats from webcams, and there's all like types of formats, and some of them combine all of the channels. A lot of them work on this concept of separating the luminance or the brightness values from the color values, and they'll use more bits for the brightness values because that's how our human eyes distinguish. They're better at distinguishing luminance than color. So you utilize that a lot. Like the NV12, for example, just has the luma plane first and then the blue and red planes. I don't actually know how the blue and red planes work because you probably need green in there too, but that one's called the NV12 format. Yeah, a lot of them work somewhat like that. Here, we probably want a Z pix map, I'm thinking. It'd be simple. Z pix map. To be GRA, BGRA. Okay, the general pixel. Oh, section 8, connection setup. Okay. Let's open up another tab here with the spec. Go to section 8, which is, I don't know where. Is this section at the top somewhere? Well, maybe let's look for connection setup, maybe. In visual information. Okay, maybe that's what we want. Okay. Screen information, server information. Okay, this is near the top. Okay. A given visual type might be listed for more than one depth or more than one screen. Blah, blah. Where's zpixmap at? zpixmap. Okay, maybe get image will tell us. The request returns the contents of a given rectangle. The x and y coordinates are relative to the origin. Okay, define blah, blah, blah. If x, y, only the bit planes specified in the plane mask are transmitted. Oh, that's interesting. You can like request like only the red information. Okay, so they always appear in a certain order. If zpixmap is specified, then bits in all planes not specified in the planes are transmitted as 0. Oh, okay. Weird. That's like so weird. Like, why would you ever need to only request a certain color of the image? Range checking is not performed on plane mask. Extraneous bits are simply ignored. Cool. The returned depth is as specified. So is depth what is depth? Is that like the number of colors, or is it the number of bits per pixel? The returned depth is specified when the drawable was created. Oh, when it was created, okay. Okay. So what do we pass for all that? Let's look at our graphics context. Create GC, here we go. It didn't tell me much, but our logging might have some information here. So, like, where's depth at? Oh. So there's multiple formats. Okay, so it tells us how many formats there are. Okay, so I bet you the zpixmap will depend on which format our window is. So how do I know which format we're using? I'm guessing this is the list of supported formats, and then we're probably using one of them. GC, maybe screen root. See, when we create the GC, we're just telling it an ID. We're giving it a drawable ID, and then I'm telling it like the background and the foreground color, and that's about it. What about the formats? Let's see. This is all, I believe this is all returned from the create window call. Let's look up create window. Okay. Let's look up the actual create window command. Okay, where's the formats? Okay, we're on page 12 here, format. Okay, we went down 2 pages already. Now we're on page 17. Where maybe these formats don't come from create window. Where do these come from? Where are we printing these? So this is coming from our common file, which kind of like negotiates the connection for us. It sends a connect setup. Is it connect setup that's giving us the formats? Yes, connect setup, okay. Is it con setup or something? Or is it connection setup? connection in it. Oh, this may not actually be a command. Read connect setup header. So this is kind of like, it diverges from like the normal X11 protocol a little bit here. But okay, we've got a header, and I think the header is like a fixed set of data that the server sends, and then after the header, yeah, so this is like the fixed portion, and then after the fixed portion, I think you can calculate how much the rest of the dynamic portion will be. And like here, we get the format count, for example. So yeah, it is in the connection setup. So format. Okay, server response. Okay. Pixmap formats. Okay. The byte order for images is given by the image byte order and applies to each scan line. Which format are we using though? Get format list. Get first screen. A bitmap, or I think bitmap's probably more complicated, so we'll probably try to do a Z format instead. Pixmap formats contain one entry for each depth value. Oh. One entry for each depth value. Interesting. So yeah, all these depths are different. So is the depth just like a way to identify one of these formats? Kind of seems like it. Oh, okay. So I think we just set the depth in our put image, and whichever depth we pick will match one of these formats, I'm guessing. So okay, let's just set the depth to 32, and then we'll have 32. So like, or 20, we could do 24, and that would ignore the alpha value. Okay, cool. Let's try it. So, oh no, I need to go back to video server. Okay, so let's set our data. See, what do we want it to be? Let's set a width and a height. So const width equals, how many pixels do we want? Let's say 200. Const, what is our actual width? It's 400. Okay, so 200 is good. Height equals 200. And then data we'll say is width times height times const bytes per pixel equals 4. I don't know if you needed that, but cool. So we got our data, and now let's like populate it with like something to draw. So let's go through each row. So var row equals 0, while row is less than height. Actually, do we want this to be U32s? Yeah, maybe we'll do it that way. And then we won't need that. Okay, so row plus equals 1. And then we'll keep track of a data offset. And then var column, while column is less than width. Call plus equals 1. Data, data offset equals, and then I don't know, OXFF 00 plus call we'll like it'll be all blue, and then we'll like have a green gradient, I guess, based on the column. That's probably good for now. Okay. Okay, so we've got our data. We will need it. Let's call this data U32 maybe. Okay, so now we need to get our actual const data U8 equals int, no, pointer cast. Let's cast it to a pointer of to U8s. Data U32.putter, and that'll be from 0 to data U32.len times 4, or we could do times bytes per pixel. Okay, so now I've got our data U8, so data, actually let's save the pointer. And then we'll make a slice, data U8 slice equals x.slice U32. How do you make a slice? .init. And then a length. Let's try that. So now we've got our data, we'll just call it data U8. Cool, so now we can actually allocate our message on the stack for now. So const or var message x.putImage.getLen of data U8. And then we will copy our data into it. We could even avoid that copy. Well, it'd still have to copy it from somewhere, but let's not worry about that right now. So message.serialize, we'll just call the normal serialize, and then all of our arguments, and then we'll send it along. How do you send things? This. There we go. So we have to pass our arguments, but we'll let the compiler tell us what those are. Needs to be a bar, 264. I need a semicolon, or this needs to not be an equals. 271. Data U32. Data offset plus equals 1. Don't want to forget that. Okay, expected U32 got usize, so int cast U32. Cool. And there's no pointer field, that's right. I need to do that. Okay, what is my slice? What is my slice, x/slice? How do I make one of those? I guess I don't have an init function. .len. Cool. Okay, expected type U16, found slice. Okay, we'll just cast it. Can I evaluate constant expression? Okay, so we're gonna have to calculate the length separately. So we'll go const len U8 data U8 len equals width times height times bytes per pixel. And then we'll data rate len. I think this should, like, one day Zig will be able to do this, but today is not that day. Data U8. Like, it should be able to have a slice whose data is runtime known, but its length is comp time known. One day. Oh, UI, that was supposed to be U8. And why do I have an unused constant? Because I'm not putting it in here yet. Integer value 1600 cannot be coerced to type. Oh, is my image too big? I think my image is actually too big. Is that true? 160,000. Is that how many bytes this would be? 200 times 200 is 4,000. 40,000 times 4 is 160,000. Okay, so we immediately see the limitation of this command. We're going to have to be breaking up our images into many put image commands. Okay, so what's our, let's see, can do 60,000. So if we decrease this by half, but if we decrease it both by half, that should be a fourth, which should give us 40,000, which should be okay. Okay, cool. I think that's how it works, maybe. I think that's got to be an ampersand. And, oh, it needs to be a U16. Oh, maybe that's why the length didn't work. I thought maybe it'll work now. No. Cool, now here's all of our fields. So we need the format, hard-coded to my machine. Oh no, format's going to be like a .z pixmap. It's the depth that'll be hard-coded. Drawable ID. I think that's going to be like the, oh, just pass it in, it's drawable ID. .gcid. I think I pass in two GCs, a foreground and a background. I'm going to guess foreground is what we want. .width equals width. .height equals height. .x equals, I don't know, let's put it at like 20. .y equals 20. Left pad. Okay, what is left pad? The left pad must be 0 for zpixmap. Well, there you go. For bitmap and xy pixmap format, left pad must be less than the bitmap scanline pad. Okay. So bitmaps support scanline pads. That's cool. Left pad equals 0. Depth. Here's the hard-coded. 32. Hard-coded to my machine, which depth format with okay, why has no zpixmap? Because there's no underscore, I think. Cool, we're making progress. Looks like there was a bug in here. Is this normally comp time, get len? Oh no, I do have an int cast normally, okay. 1154 has an issue. Enum to int, I think. Oh, this needs to be updated. Good thing I caught that. Oh, let's double check that our math is right here. Put image, so 1, 2, 3, 4, 8, 12, 16, 20, 21, 22, 23, 24. Yes, 24 looks right. Args.width needs to be an I16. Should be X, and that should be Y. Man, look at all these mistakes. Okay, well, theoretically, it should work. I don't have high hopes, but okay. So we ran and immediately got a crash. Probably we got an error. There's something wrong with our command. Let's see what the error says. We do actually get an error command here. It says error. It says put image, so it knows we were trying to send a put image, and then I'm not sure. This might have tell us something more, but I'm not sure. What is match error code? Probably means something. If we look up error code match, what is this? Match error results. Oh. Let's see what xtrus tells us. Xtrus. So xtrus will just automatically print out all the commands it got. So it saw our image text 8. And then here's our output, put image. Okay. So it looks like it did get width 100, height 100, 20, 20, left pad 0, format zpixmap, and then image data. And then it's getting, okay, FF. Okay, yeah, this is looking good. Bad match. Okay. I don't know what that means. Match. Match. What is this match error? Oh, it's like our format match isn't right or something. Does it say zpixmap? Yep, zpixmap. Where's depth? 32, okay. Format 32, okay, yeah, okay. Scan pad is 32. I wonder if that's a thing. Huh. Let's see. If bitmap format is used, no, it's not. For X and Z, the depth must match the depth of the drawable, or a match error results. Oh, okay. So what is the depth of our window then? Oh, looks like it's 24. Okay. So that might be our issue. Let's just change it to 24. That kind of makes sense. Like the window doesn't have transparency, so it may not even support that depth. Did that work? Seems like it might have worked. Although this isn't what the image I was expecting. Let's go, it's just all green. Let's try doing something like This should be an or actually. And then, oh, there's a couple of people. Oh, Christoph rated me. Cool. Dear Twofold Twitch. Yeah, it's been a while. How's it going? Oh yeah, am I making my own OBS? Yeah, I'm like working on streaming software at my job. I just went through and implemented webcam capturing code, and I'm like, oh, I could just do this in Zig. So right now I'm working on like displaying an image in the X protocol using my Zig library. So it's going to be a Zig like bottom up solution for streaming. So I might use libyuv, which is kind of like it's got like assembly and optimization in it, but yeah, no, it won't even take me that long to do. So I'm probably gonna I'm thinking about putting up my own security system, like with cameras and stuff and Raspberry Pis. So I want to like implement it all in Zig, and I don't think it'll take that long. So that's everyone's last words, right? So anyway, yeah, I just got to the point where I can actually put an image onto the screen, but it's not the right color now. So I just implemented this new command, X command. But yeah, welcome to everyone. How was Christoph's stream? I started to watch it for a few minutes there, and then I started working on this stuff. Okay, I was gonna add some more color to this image, see what's going on here. Let's see, row, and FF, shifted over 16. Hopefully that gives us something. It's still all green, which is weird because maybe I just don't understand the image format. Because XTrust is saying, okay, well, this is looking valid. Okay, what if we just hard code it a little differently? Like, what if we do like that? It's still green, huh? Why is it just green? Data U32 equals FF0000. Will that make it red? No, it's still green. It's a bit changing green. I should pull up Bork here so I can see. It's a bit. Wait, are you giving me a answer, Dear Twofold, or what? Can I make it white? Like, what if it's all Fs? Why is it still green? What the heck? Oh, hold on. I wasn't running. I wasn't running the new command. Whoops. Okay. Okay, here we go. Let's go back to this one. Okay. Let's get rid of this hard-coded stuff. Okay, so it should be a gradient here. There we go. Okay, so we have implemented sending images over the X connection. The thing that we learned about this is we can only send 100 by 100 images. So for like a webcam image, which is, 640 by 480, we'll probably need to send like 6 times 4, 24 of these images. We'll have to break up the image into 24 smaller images to send it like this. This is probably why X uses shared memory. But it's okay. We're going to implement it anyway like this. Very cool. So I'm trying to think of what to do next. We could like start going into like the actual image capture stuff. It's probably going to take like a good hour or two to like actually get webcam images like on the screen and showing. Or I can try to like work on this a little bit. I'm trying to just think of what would happen next here. I think the next thing might be to get actual image capture. Well, I suppose we could implement the logic to actually transfer a full image in pieces. That could be the next piece. Yeah, maybe let's look at that for a second. So we'll like have a function here, fn send image, and we'll have a like width. So this could be like any width. I'll just say U32, height U32, and it'll be a bunch of these put image commands. And what we'll do here is we'll just have the maximum data size. So we'll allocate this data on the stack. So var data, and this is going to be, what's the maximum size of an X11 command? I think it's probably the max size of a U16. Actually, it might not be. I don't remember. I'd have to look at but for now we'll just assume that it's standard math.max int minus x.putImage dot data offset max data. Yeah, let's put this in its own variable. Max data U8. Okay. Okay, so we'll have to like, let's start out with just sending the one image. Width, height, let's see, how do we want to do this? We've got our data, so we'll move all this stuff out of this function. Actually, it's already up here, so we'll just call send image, width, height, and then our data. So it's going to be data U8 footer. Actually, this will change a little bit. So we've got our data U8 0, data U8 len. Okay, so we'll just pass in a slice here. Get rid of all this. Okay, width, height, and then data. Cool. Data const U8. Okay. So we'll just assume that we can send all of it at once for now. So data U8 putter. Data.putter, we don't really need that anymore. Int cast U16 data.len. Okay. We'll need to get these variables. We'll need to calculate those for each subimage. Okay. $282 void. Oh, I need to also pass the socket. Yeah. Sock. Probably I need a try here. And yep, I do need a try. And I'm missing something like a colon instead of a comma. Data U8. I did not define data U8. Putter. OS. Data. Oh, okay, so this is, just call it in data for now. Let's, now let's just comment out this one for now. 296. Oh, okay, we also need the rest of our data. So let's put this on new lines. We're gonna need a drawable ID and then a GC ID. Drawable ID, FG GC ID. Oh, we'll also need an X and a Y. I16. 2020. Looks like we're going to be new lining this as well. Cool. Shadows declaration of X. Oh, because X is the name of the library. Zig format. What? What are you talking about? Zig format. What's that? Oh yeah, because Zig format would new line that automatically, wouldn't it? Interesting. I don't use Zig format because some people will use it on save, but I have like OCD about saving. Like I'll save like when I'm in the middle of typing like that, and then it'll like mess everything up. But it'd be nice to like figure out how I could actually integrate that on save. I'm not sure yet. Center, yeah. Okay, so here's the issue. My library is called X, but I have this X variable, like X position, I guess. Yeah, let's just go with that. X pos. It's X pos and then Y. All right. So what is this supposed to be? I'm so mad. X lock. Wait, what's X? X lock? Oh, X loc. Sure. Let's see. Oh, found U32. Okay. So this needs to be a U16. Oh, because the width and height aren't comp time known anymore. That's why. Actually, this will probably fail because of that. Yeah, so what's going on here is I'm out. Yeah, let's go back to this. I'm allocating this on the stack, and I'm using this get length code at comp time to calculate the length so I can allocate it on the stack. It's like I'm like utilizing Zig comp time to get one of these really cool features. But now that I'm making it a function with runtime parameters, I can't do that anymore. So what I'm going to do here is I'll just allocate the maximum, because the maximum message you can have here is 65,000 or whatever. Actually, now that I think about this, this should be, I did this a little wrong here. So our actual message will allocate on the stack. And I think the maximum message size you can have is a U16. And then we are actually going to copy it. Serialize no copy data, I think is what I called it. And then we'll do like a mem copy or something. This is where you might want to use libyuv, which has like assembly implementations to like copy data and stuff. So I might end up including libyuv at some point and using Zig C compiler and maybe Zig libc at one point. So, but for now, we just need to copy the data. So how do we do a copy? We could do standard mem copy, or we could just do mem copy. That's probably the best one to use here. So we want to go at message plus x.putImage.data offset. And then we want to get our data and then our length. So what is the length? It's data u8 len. To do use live YUV for fast. Data UI len. Yeah, that would be a mistake. 1, 2. Okay, I did not call it no copy data. What did I call it? No data copy. Of course. Of course, it's no data copy. Okay, what are you complaining about now? Why is width a U32? Oh, because it will be a U32 at one point. To do remove this. No, I don't need to do that because this is all gonna have to get changed anyway. And we actually split the image up. Integer value 24 cannot be coerced. Yeah, I wouldn't think so. How do you do that? How do you pass an offset to an array? How does that work? It's like, maybe I do it like this. Sliced. Okay, yeah, it was sliced. Okay, did that actually work? Oh, I think it did. Let's change the image a bit just to double check. Do like the same thing here, but shift it over 8 so we get some green in there. Yep, there we go. Very cool. So now we could send multiple images. We could send one there. We could send one at, let's try sending it at 130. 130. Should be the same image. It doesn't look right. Did I not pass X and Y correctly? Why didn't that work? What did I do? It ran so fast I can't, like, I'm not even sure if it built anything. I think I'm using, am I using the new compiler? Is it the stage 3? I'm not. Should I try using master right now? I'm a little afraid. Ooh. Oh, this is that error that Andrew got when he was trying to upgrade Zig up on stream. My git repo steps using null in one of the don't, it's flaky. It doesn't like null for one of these. Like, I think it's, yeah, the error message line numbers were not working, but he had like, he used the AST, he used these magical Zig commands to like look at the AST, and then he saw it was one of these optionals. But okay, let's go back to our, let's see, I have a, let's see, which one's the one I had before? I think this is the 3.6 is the one where stage 3, but there's a 3.5 that, the one before. So this is the one before, the 3.5.5.9. Let's go back to that one. Okay, so why is my image not, second image not working though? Maybe let's do a xtruss real quick. Xtruss, that'll give us a trace of all of the X commands. Video server. Let's close it, and let's see our put image commands. So put image. Okay, we see the one that went to 2020. But where's our second one? Very odd. Oh, by the way, that's my Zig format. It's the Emacs. The Emacs formatter. I don't think the Emacs formatter calls the Zig one. That'd be cool if it did. Somebody get on that. Okay, is that a lot? I'm confused at what's happening here. Why are we not getting the second command? X lock Y. Oh, why do we get a seg fault? Are we getting a seg fault? Oh, it's right there. Oh, you know what it could have something to do with, like, we're not, the length of our command is not aligned properly. And so it, oh, I know what it is. We are sending this entire message, not the actual length of the command. We need the actual length of the command. So const message len equals, what is it? X.putImage dot get len data u8 len. Did UI again? I've done that like 3 times. So message 0 message len should be what we want. There we go. There's our 2 images. Awesome. So we could, like, have one image be with the green, and then we could change it here if we wanted. So the challenge now is to make this send image actually work with, like, larger images. So how hard is that going to be? So I have to do, like, math and stuff. Let's see, we could probably, maybe what we do is we implement it, like, send it like we break it up into 10 by 10 pixels at a time or something first. And then we just assume it's aligned for now. So how would that work? So we go like const max large images over a socket. That doesn't sound very efficient. It is. I don't think it is either. So the plan is to implement it first using this put image command that X supports. And then I think what normally happens is most applications that do, like, pixel-based rendering use shared memory. Like, for example, very relevant to my previous streams is Doom. The Doom source code has X11 as its backend, and it uses, I know it uses shared memory. Now, the disadvantage with shared memory is it won't work remotely. But it's not as super common to have it work remotely, but I do like having the option for it to work remotely. So I kind of want to have both, you know. I want my cake and I want to eat it too, so. Let's see. Where's all the Doom files? Git Doom. Oh, it's in here. That's right. So Doom's interesting. It, like, prefixes everything with a letter. So I think G might mean graphics, or maybe not. What's stopping you from using lib Wayland client? Waypipe is possible for remoting. Well, Yari, I got a question for you. Is lib Wayland client in Zig? Let's see. Oh, it is? What? We might want to use that if we support a Wayland backend. Oh, bindings are a bit. So it's not actually written in Zig. Yeah, so I guess like I could explain like the reason why I'm doing this a little bit. Like the main reason why I'm doing this is I want to, I created this baby monitor that will, has like a little camera on it. Oh yeah, I got it right here. It's all like torn apart right now, but you've got the Raspberry Pi, you've got the little camera. So we used that for like a year with my little Babu, and she being the Raspberry Pi died after about a year. I don't know what happened, it stopped working, but at that point I was like so busy with things, I was like, I'd rather pay $120 to buy a monitor rather than like spend 2 hours trying to figure out what's wrong. So we ended up buying one. But now I'm kind of like wanting to get into home security cameras. So I'm like, okay, let me take a couple days and see if I can get some of my code running to do security cameras. And with my job right now, I just got done implementing code to be able to capture webcam data from on Linux. So I have all that like fresh in my head. I'm ready to like sit down and go and implement that. And then on the other side, it's displaying the actual video. So right now we're just working on displaying that video in a UI. And the ultimate goal is I'd like to be able to have a UI library that I can use in Zig, something that can work with Wayland and X. So yeah, maybe I'll end up using libwayland client if you said it has Zig binding, so it's probably written in C. And I'm okay with like using other libraries that aren't necessarily in Zig, but I just want to use good libraries. And I find that a lot of stuff just isn't good. So like, for example, GTK, like I'm not going to use GTK. I've been like bashing my head against the wall using that for the last 6 months. So I need a better UI alternative. But one that I saw that was kind of interesting was IMGUI. Is that how you say it? And I'm not like quite sure of all the trade-offs. UI is kind of like a really complicated subject in general. So I'm still like exploring that area and what's out there. There's a Zig UI project that like looked kind of interesting. It kind of looked like a GTK style. Is it this one? Somebody like posted it on Reddit. IUP bindings looked cool, but I think it's borked. Wait, what's IUP? IUP library? Indiana University. I don't think that's what you meant by IUP library. Let's see. IUP graphics library. Portable user. Okay. I did like recently look at like a whole bunch of different UI like toolkits and things. Cappy UI. What's this? Cross-platform library for making true native. Oh. Okay. I don't know if I've heard of this one. IUP for Zig. Okay. We've got a stack going now. Haven't had a chance yet. Okay. Examples. Oh, that's cool. You've got like example applications already. Simple notepad. Oh, that looks really slick already. So wait, who made this? IUP for, oh, it's, okay, IUP is not in Zig. It's a library that Zig's bound to. this does actually look a little familiar. I feel like I might have seen this one. High performance due to the fact that it uses native interface elements. Okay, this could be like something I was thinking of implementing in Zig, but maybe I wouldn't need to. Cross-platform, but the build might be borked. Made by the Lua guys. Available on SourceForge, huh? Let's take a quick peek at the source code. See what it looks like. Oh, that was interesting. Okay. Documentation, download. Okay. Interesting, it's not on GitHub, but that's... When stuff's not on GitHub, the first question I ask is, how easy is it to contribute to? Like, are they using patches over email? And the problem I have with patches over email is whenever I send contributions to projects like that, they just get lost. GL with your search for the ultimate. Good luck with your search for the ultimate Umar setup. Time for me to go to bed. All right, Christoph, Loris. We'll see you around. Thanks for dropping by. Okay, docs and sources. Oh, is this like all the dependencies? So you gotta like learn how SourceForge works. Let's take a quick look at this. Did you get... Oh, is that gonna work? It's gonna be called download. foo.tar.gz. I don't know if it's gonna explode, so let's extract it safely. Oh, it didn't explode. Cool. Okay, so what's in this IUP folder here? Scintilla, plot. Oh, it looks like it's a bunch of stuff. A bunch of libraries, like. Okay, so is this like using Lua under the hood? I have to guess that if they are using Lua, that they probably have a lot of, like, it probably supports like dynamic plugins, although this is just a UI toolkit, so I don't. Bin to C. I have something that does exactly, is this like embedding binaries inside? I have something that does exactly the same thing if that's the case. C, I think C20 just implemented hashtag embed. Is Google gonna? Yes, this one. This is an interesting read. The guy is basically talking about how he tried to get hashtag embed included in C23 and just having to deal with people on the committee and people giving him resistance the whole way. And yeah, C23. This is an interesting, and this is a great summary. I totally like relate with that. I did a lot of work on the D programming language back in the day, and I did end up getting a feature into the D language that lets you include the source file name using a macro. So I had a couple of use cases for that, but it was like a pretty long debate and having to deal with a lot of like negative people. I think like the D-Lane community, I don't want to like bad talk them, but the community is definitely not as awesome to everyone, or people aren't as welcoming or aren't as awesome to each other as they are in the Zig community. And that's, I think, a stark contrast between the two. But like I said, I don't want to like bad talk them or say that say anything bad, but it's a big stark contrast. I'm much happier with how Zig runs things, and much happier working in this community. Yeah, so let's wind up the stack here. Yeah, IUP does look interesting. I don't know if I'm super stoked about some of it being written in Lua, but maybe there's a good reason for that I just don't understand. Cappy though also looks interesting. Yeah, maybe this does. I have looked at this. I remember this. I remember seeing this example here. Cappy. Let's see if it works on my system. It's fun. Like, Zig's so cool because you can just download a project and build it, like, and run it. Like, there's no other language like that. You can't go and just look up random C and C++ projects and build them. It's like, okay, you got to block out some time. You got to make sure you got all your dependencies in order. But with Zig, it's so fun to just like download a project and run it. And you know, because the language is, it's ironic too, because the language is changing so quickly. Yet I still take way less time to build a Zig project than I do a C project. Yeah, so let's take a quick look at this Cappy project though. This looks interesting. Cappy Zig build. Okay, so this is a Zig Mod project. I've only built a couple of Zig Mod projects. Let's go download Zig Mod. Let's see. I just tested 40 projects in Zig and only 5 compiled. Yeah. Don't get me like wrong. Like you're not gonna have like 100% build rates. Like 5 out of 40 to me is pretty amazing. Wait, aren't you listed as a contributor for what? For Cappy? Am I? I am. Why am I a contributor? Did I contribute to this? It's very possible that I have contributed to this. Fix Windows. January. What? What is this? I have no memory of this at all. Path join. Wait, okay. Maybe I do have memory of this. You know what? This was in January. This was a lifetime ago. Back in January, I was a completely different person because I used Windows. And I don't really use Windows anymore. Yeah, it's not just Zig. C and C++ are the worst. Yeah, well, the thing is with Zig, when the language actually stabilizes, when we get to a point where C is, you're gonna get 90% project build success. It's gonna be really high. That is so funny. I don't really remember doing this. I kind of maybe have a vague memory. But hey, we're not on Windows anymore. We're on Linux. Zig. Oh yeah, I need Zig Mod. Releases. Let's see. We could try to build Zig Mod, but I've tried that before and I wasn't successful one time. Okay, so is that just like a binary? It could be CP Zig Mod. It is. Okay. So how to Zig Mod? It's like, what's the command? Does it say here how to do it? Zig Mod. Sure, it'll say here. Build from source. Zig Mod. Yeah, I think it's Zig Mod fetch is what you want. Okay, so it downloaded Apple Pie, and that's promising since that's the one it said it couldn't find. Why is it? I wonder why it's using Apple Pie. That's interesting. Apple Pie is an HTTP server that I have tried it out before. It was pretty nice to use. I actually was trying it out when I was initially implementing my baby monitor. Okay, so it's got some error. Let's see. Oh. That's interesting. Emit H equals true. Okay. C API. Let's just not do that. How about that? Why did they switch from Windows to Linux? You still have a dual boot. Assume that means dual boot to test Zig. I don't have to dual boot because I have another solution. Multiple computers. So I still have my Windows computer still running all the time, and if I want to ever game, then I'll switch over to that. I don't game a lot, but my Windows computer's got a beefy RX 6900 XT AMD graphics card, so I definitely want to be playing games on that one. This one, I switched to, the short answer is I switched because of work. So I worked at HP for 12 years, and we used Windows over there. And so that's what I used at home. And now I'm working for a new company called Tuple, where we're doing like remoting software, like kind of like Zoom. And my job is to make it work on Linux. So I've just basically switched my daily driver to Linux. And after that small tangent, it looks like we were able to build. What did it build me? Mind bump. Oh yeah, thanks for the suggestion. Let's get that font size up a little more. Oh look, built a bunch of stuff. I do remember these examples now. Okay. 300 buttons. Nice. This is kind of cool actually. I might have to start using this. Let's see. Counter. It feels like pretty responsive too. Like how does this Cappy work? Is it it might be using Wayland actually. Let's actually we can do something here. Wayland display. Oh, for WebAssembly. What? For WebAssembly. So what do they use? Do you know what they use WebAssembly for? Okay, let's see if we can get it to use X. They run a web server in build.zig. What? No, there's no way they run it. Oh. Maybe they do. Step used to run a web server. What? Why? Why? Wayland debug is a way to check if it's using Wayland. Yeah, I think setting this to nothing will should force it to use X because it has no way to connect to the Wayland one. Oh, and then I guess we could use that to know if it's connecting to Wayland without it. Wayland debug equals 1. Was that? Did I get that right? Wayland debug equals 1. Huh. Are we web yet? Lol. Line 125. Okay, what's on line 125? libwayland falls back. Oh, really? Interesting. Thank you, Leon. The reason why I thought that might work, and maybe it still does on my system, but the application that I work on for work uses Flatpak, and if you set Wayland display equals to nothing, and then run Flatpak, it will not create the Wayland proxy. So, but maybe that's just a Flatpak specific thing. There's like GDK, or there's XDG something backend as well. XDG session type. So mine is set to X11. You know what? I don't have Wayland on this machine. I just remembered. I have Wayland on my other machine. My laptop right next to me. But so some Wayland client developers do the Wayland display query manually, sidestepping live Wayland to avoid this. Yeah. Okay, but you're saying lib Wayland falls back to Wayland 0, yeah? Interesting. Okay. Okay, you said, who said that? Leon? Or not Leon, Lee? Line 125. Okay, so what are they doing here? They're walking a directory, looking for Zig files. What are they doing here? They're doing something nefarious here. Like they're like sidestepping the limitations of the Zig build system or something. Okay, if target is WASM, then WASM. That reminds me of the WASM 4. Like, did anybody check out the WASM 4 results? I remember Loris was a judge for that. There was some pretty cool games. There was one in particular that I really liked. I think it got like 4th place or 6th place or something. Yeah, the game jam. I thought about doing it. It looked like there was a lot of them that did Zig this time. Let's see, where's the game jams? First game jam, where's the second game jam? Let's see, I could probably go to this one. I remember it was like second. Whoa. Does anybody have the link? Second game jam. WASM 4? Game jam? See, how do you find... They don't make it very easy to find the game jam results. See, I think I have it on Discord somewhere. Okay, I think I got it here. Jam 2 results. Here we go. Yeah, Journey. I played Journey to Entourage. Oh yeah, there was some impressive 3D stuff. The flying one. Yeah. Yeah, I saw that like Zig was like one of the main entries. Let's see, I played this on my Windows computer because I wanted to use a gamepad, but yeah, this one's like pretty difficult actually to beat, which is really cool. You have yet to build WASM stuff in Zig. Yeah, it's pretty cool. I started a game when they were doing the first jam. WASM, probably have something called WASM Explorer. Yeah. Yeah, but I do what I always do, and I like got onto a tangent, like kind of like I'm doing right now. For some reason, the Xbox controller wasn't working. It works like for other things, but for some reason, the WASM 4 implementation doesn't work. But to build the WASM4, a WASM4 Zig project is super simple. Like this whole WASM4.zig project is the entire hardware interface to the console. It's literally 133 lines to interact with the console. So you compile your Zig code to WASM4, and then they're able to add hooks into like memory addresses and functions, and then it will capture those whenever you write to certain memory or whenever you call a certain function, and then emulate whatever it needs to. Yeah, WASM4 is freaking sick. Like, this is the whole thing. Like, here's how you do sound. This one function, basically. You give it a frequency, a duration, a volume, and then you can like give it some flags to change which modulator you're using, things like that. You've got a couple of storage functions, like these two functions are all you get. It's got some tracing, and then like here's your drawing functions. You can do rectangles or you can blit a sprite. And then here's all your constants. So to get controller input, you just read from this memory address. So memory address 16. And then I think this is like a bit flag with all your controls in it. It's just 8 bits. So yeah, it's a bit flag. So then you would AND it with this to see if button 1's pressed and so on. So yeah, super simple. So I don't know, would it be, I could try getting this to run. Like, it was just a little like exploration on it. W4, can I think I can download WASM4 really quick. Let's see, I think you go to learn and then go to getting started, setup, and then you can download the binary here. Like, I already have it downloaded, I just don't have it in my path for some reason. Downloads W4. I think I can just copy that to my bin directory. W4. Yeah, there we go. Okay. I don't think I've ever done it on this computer, but what did I call it? WASM4 Explore? WASM4 Explore? Okay, let's try building it, maybe? Actually, I don't know if Zig build... Oh, it did work for some reason. That's an interesting build.zig file. If you go like W4 watch or something, W4, yeah, watch. Oh, look at that. So this was my little exploration. And then when you press the buttons, it tells you which buttons you're pressing and stuff. So I think, yeah, there's like some sort of grid that you could define in here. Just like a simple little explore. Yeah, so here's how you define the level with this ASCII. Then here's was the sprites I made. 1 bit per pixel. So you only get 4 colors in WASM4. So what you do for a sprite is you get 2 colors for every sprite. Well, for 2 bit per pixel sprites. And so you either get off or on. And so you can literally draw your sprite using binary literals. So you can kind of see what the image looks like from the source code. Oh, and then an animation. So you Smiley, I think, is the character here. So you can see his little legs like going back and forth. So there's little legs right here. There, it's to the right there and to the left there. So that's kind of how it works. Music. I thought this had music, some music in it, but maybe it's commented out. I actually submitted a proposal to make the music a little bit better, but I don't know if it ever got integrated or not. It was going to be tough, like, because you'd either have to create like a way to enable it for new games, but keep the old behavior, which we could do pretty easily, but it's like, yeah, I don't know. Yeah, maybe a driver issue had to disable native Linux driver for my PS4 controller. Oh, really? Interesting. Huh. Okay. Oh, I did want to show you guys my favorite game from the Game Jam. Check out all the WASM4 games on Wapom. Here, maybe it was this one. Yeah, Journey to Honduras is a really difficult one. Samurai Revenge was pretty cool. This Galdar, I freaking loved this one. Check it out here. Okay, so this one's like all about doing these key combinations. So you're a wizard, and on the bottom you can see, like, if I press the right key, it'll highlight that right key, and then the button 1 will complete the spell. So you kind of like go on this adventure, and the combat's really fun. So let's show you what a combat looks like. Okay, so here's a combat. So you just press the sequence to cast the spell. So right now I'm fighting a bat, and he's about to cast vampirism on me, and I'm just casting the shade spell like over and over as fast as I can press the key sequence. So he'll never like get past my shield at this point. I have 103 shield, so he's about to hit me for 5. So now I'm at 98 shield. So I just casted the shade spell, which gives me shield like so quickly. It just, I'm just invincible at that point. But it's, now I can do an attack spell like by doing that little sequence. And there's a little bit of strategy when you pick spells, because you can have them overlap the sequences, and then you'll cast both of them. So yeah, anyway, I thought that was a really fun game. Like, definitely check it out. I thought it was a really cool concept. Yeah, the graphics are cool. Yeah, like if you're like fast enough, like if you're going as fast as I was going there, like you should be able to beat the game. I will say, like, the very like to beat the game, I was like furiously like tapping as fast as I could to get my shield up, and I was barely able to not die. But like if you actually got some like good spells and stuff, but I think I could beat the game with just the starting spells by just typing fast enough. So, but it's super fun. The impressive one, I think somebody mentioned the 3D one. There's this asteroids one, which is just like impressive. So this person was able to create full 3D movement with the arrow buttons and one button. So by holding the control button and pressing like up or down, that'll like speed you up or slow you down. If you're not pressing the button, you'll go up and down. And then if you press left and right with the button press, you'll roll. So like you got all this 3D movement using those controls. And I could not figure out what to do in this game. I just like was mesmerized by what this person did, and just flew around for like 10 minutes, like not knowing what to do. But was just so impressed by it. It's cool. So anyway, that's another one. I'm pretty sure there's some objective to it that I'd never figured out. Yeah, probably a math wizard. Yeah. So that's all I got to. After I got to this one, I was. Oh, Minicraft. No, I did check out a couple more of these. So you get like Minecraft. I was like, okay, how did they do this? Oh, you can use the mouse too, like in this one. So they made Minecraft basically. So that's another fun one. Fun idea. Wait, one slime army? Hold on, hold on, what? Oh, okay. I was gonna say, is this based on that one slime game? If anybody knows what I'm talking about, oneslime.net. Is it still the same address? Oh yeah, slime volleyball. So I played this game in high school and got like mad good at it. And but it was written in Java, so you had to like use a Java applet to run it. So I at one point like I wanted to play it again, and so I decompiled the Java and then converted it to an HTML5 application and then submitted it on GitHub. And I think it's like one of my most starred projects on GitHub. And then like a year ago, like we're talking, this is probably like 15 years ago that we were playing this. But like a year ago, he decided to port it to HTML5 as well. So now I can finally play his version again. And then I'll show you my version here. Slime JavaScript, I think is what I called it. Yeah. I don't know if this link still works, but oh yeah, I updated the graphics, or you could go back to the legacy graphics. And I added like backgrounds and yeah, these were the days. It's running a little slower, I noticed. It's interesting. But yeah, I tried to get like the physics exactly the same as the original. But yeah, 33 stars, my most starred project on GitHub, I think. Anyway, games, fun stuff. Yeah, I'm not like I think like we're kind of at a point where we have to do a bunch of math, and that's going to be kind of boring to do on stream. So maybe we'll take our game exploration, have that be our happy ending for the stream. But thanks for everybody joining. It was cool hanging out with you guys and talking about programming stuff and games and stuff. Hopefully I'll keep doing some streaming more often. I want to keep doing it, so I'll try to get back to the Zig libc stuff at some point. We'll get Doom compiling with Zig. We kind of left off. We had just gotten X11 to compile with our version of libc, I think. So yeah. Lots more fun to come in the future. So again, thanks for coming, and I will see you guys around.